All right, guys, welcome to Unit 6. We are talking about rigid transformations, congruence, and triangle proofs or congruence proofs. We're going to start off with the very basics, and hopefully these videos are going to help you sort of understand some of the vocabulary a little better and be able to visualize the three rigid transformations that we're going to talk about over the course of this unit. They're sometimes going to be a little tougher to visualize, so hopefully this will be helpful for you to come back and review. To begin, though, we need to start by talking about what is a rigid transformation. Now, a rigid transformation is any transformation, meaning any changing of an image, be it any shape. So let me pull a few of these up. Any changing of an image, such as rotating an image, possibly, such as translating it, meaning moving it somewhere, rotating, as we already said, or reflecting the image, that results in what is known as a congruent image. Congruent image. Now, in this case, well, in all cases, what congruent means is that the shape has the same side lengths. It's the same size. All the sides have remained the same length, and that the angles have remained the same. So the idea is I could take this poorly drawn shape that I'm about to fill in right here. That's terrible. I can take that and move it somewhere if it wants to cooperate here. Shouldn't have written there. Let me try that again. So the idea is I can take, I'll just do it in here actually. I could take any image like this poorly drawn triangle and I could move it. Now you'll notice while I'm moving this, the size of the shape has remained the same. It has not grown, it has not shrunk. Now obviously in this case that's pretty easy to see because it's just moving around like this. Now that would be called a translation. Translation. But there's other kind of rigid transformations that I could do, such as what if I wanted to turn this shape? Well, I just turn that shape 90 degrees. If you notice, let's clone it, and we take it back to its original orientation. This shape has not changed in size at all. It's remained exactly the same size, and the angles have all remained the same. All that's happened is turned. Now, that is called a rotation. So far you've learned translation, rotation. Oh, come on. Why are you being like this? And rotation. There we go. And the final one we're going to talk about is called a reflection, which hopefully should be pretty easy to see. It just reflects. Now, I'm going to clone this and show you what the original image looked like again so you can see what I mean by reflecting. It's just simply become the opposite of itself. Now, I can't duplicate that shape by turning this. You'll see the orientation is off. So I've actually reflected it as if there is a mirror right there. That's terrible. There's a mirror right there. So translations, where we just move it, rotations, where we turn the shape, and then reflections, which you've definitely experienced with mirrors and things along those lines. So those are the three rigid transformations we're going to talk about, and they create congruent images, which again, congruent means that the shape has remained the same size and the angles have remained the same. There is one fourth kind of transformation that is not rigid, and that transformation is called a dilation. We are not going to talk about dilations in Math 1 this year, but here would be a dilation. There's the original image, here's the new image. Now you can see it is no longer the same size, therefore while it has remained similar, which means that the angles have remained the same and the sides have remained the same in relationship to one another, the size of the entire shape is different, therefore it is not a rigid transformation, therefore it is not congruent. So, a couple other little pieces to get into on this vocab. The resulting image after a transformation it is labeled as something called prime, which we literally just write with an apostrophe like this. So an example of this is, let's say I have triangle MNO, which is this triangle. Let's just do this again and make a prettier triangle. So we have triangle MNO. Now you get what I'm going for. MNO. Now, if I were to translate this image, and let's say we translated it over here, and then I take this image, and it's been translated, this new image, we have to give it a name. And the name we give it, the name we give it is, I broke Smart Notebook. The name we give it is M prime N prime O prime. That's the new image. Now, if we were to translate it again, well, we are going to, I definitely broke Smart Notebook. So if we were to translate it again, after this initial one, and we were to translate M prime N prime O prime, we would actually get a new image that would be called M double prime M double prime N double prime O double prime and triple prime, quadruple prime, so on and so forth. And this simply lets us know that this original image has changed once, then twice in this case. And again, it can continue to go like that. Hopefully that cleared up some issues, any confusion you might have had, or got you prepared for this unit. I'm going to continue to record these videos once I get Smart Notebook to stop freaking out on me. Thanks, guys.